Hi friends, welcome to my channel Code Destination. So today we are taking the topic sorting algorithms. So today we will discuss bubble insertion and selection sorting algorithm in detail, and we will also discuss the logic behind this, and after that we will code. So let me share my screen. Yeah. So for explanation purpose, let me share my whiteboard. Yeah. So if I talking about the bubble sort, so what is the algorithm behind it? So there are one example I am taking this one. So for this example, we can see like how the bubble sort work. Like the name already suggests that bubble means like there are some bubble, we are just swapping that bubble to each other. So let me discuss how we can swap. Like, so in the bubble sort, what we check generally, like we generally check the neighbors element. Like in this case, suppose there are this is the our array. So I want to sort this array. So for every index, I will check the neighbors. Like first I will check this 29 and 10, and if it is like first element is greater than, so we will try to swap them, because what our end goal is here, we want to get the largest element at the last position, because we want to sort them in the ascending order. So in the first iteration, what it will do, like 29 is greater, so it will just sort that. So here 10 29, okay, sorry, it will swap here, and 37 and 14, so it will present. And after that, it will come here. First iteration was starting from here, then in next iteration we will come here, then it will check these two element. If the first element is greater, then it will swap again. So 14 will come here, 29 will come here, okay, 37 will come here, and 14 come here, okay. In the third iteration, it will start like the third iteration, it will check for this one. So what it will do, uh, it will check this element to this element in the third iteration. So 10 14, that is already greater, that 37 is already greater, so it will not do anything, it will just move a index for the next check. So in the from the next check, it will go here, it will compare this element to this element. So this 37 is greater, so we want the get element the last, so we will swap this. So here it will swap 14 to the 37. So in this way we can see, like at the last for every iteration, at the last we are getting the 37, which is the largest element amongst all the element. So bubble sort basically define this behavior, like in every iteration, like for the ith, like we start from I0, and from I0 for, like we start till end. So after this iteration complete, we get the largest element at the last. So again we will start from here for next iteration. So let me start. So again it will check this two element. So if that 14 is already greater, so it will not swap, so it will be as it is. 29 will be here, 14 will be here, and 37 it is already sorted, okay. And like for previous, I will make the check till here, but like we know, like this is already sorted. Let me highlight it. So like we know, like till this index the 37 is already sorted, so we didn't need to check anything after that. So in the, like when we start the next check from here, so we'll run like we will check till this index. So we will follow that method as well, because which is the things which is sorted, we didn't need to check again and again, okay. So this is check. We start iteration. So for this it is already sorted, so it is just move for this element, it will check to the next element. So this is already 29 is already greater than 14, so it will not do anything. So it will come directly here, okay. 37 will be here. In the next check, this 29 will be checked with the next element 14. So 14 is less than 29 and 29 is greater than, so 29 will swap here and 14 will swap here. So in the next iteration, then 14 will be go here and 29 will here. and as we discuss, we will iterate till here. So my iteration is done. So as we can see here, till this two iteration, previously the 37 was at the right place, now 29 is the at the right place. So in the next iteration, this two places is already sorted, so we will only focus till this index because this two element is already sorted. So in this way I will again check the further iteration. So I will start again from starting. I will check this 10 and 14. So 14 is already like getter, so it will not do anything. 14, 29, 37. Then again it will check this is completed. So it will check this 14 to this 14. So this 14 is like equal, so we will not do anything. So 14 will be as it is, and 29, 37. So we are done now till what index? Till this index we are done now. So again we will start from start and we will check only this index, because after that already all the element is sorted, so we didn't need to check again and again. So we will start from starting again. 10 and 14, 10 14 are already sorted, so it will just do 10 14 14 29 37. Okay, so in this way, like it will just sort at the last. Whatever result we are getting, we can see it is a sorted. So what we are observing here, like basically in bubble sort, in the first check it will just make the largest element at the last. Then in the second check, here in the second check, it will make the second largest element at the second largest position. And the third chase, in the third check, it will make the like third largest element at the right position. Here we can see third largest element, and like that we will sort all the like element in the proper manner. So let me write the code for it first, just following this logic. Yeah, and for visualization purpose I just find something from internet, so maybe I can share. Like for bubble sort, if I create this element and I sort, so you can observe how it is behaving, this algorithm. Maybe I can run from here. Yeah, so like first it is checking 29 10, 29 getter, so it is swap, and 29 14 it is swap, the 37 14 it is swap. At the last 37 is at the, like at last we can check this 37 is the right position. And for the next check we will check till 29, like till third index. So it will checking the like green one, like 14 29, 29 already sorted, so it will not do anything, it will just leave it. So now when this iteration completed, then the second largest element like 29 is the right position. Now it will check from 0 index to 2 index only. So now it is checking like 10 and 14. To 10 14 already sorted, so it did not do anything, and 14 14 already sorted, it did not do anything. So in this way it will complete the bubble sort. So let me write the code for it so that we can understood. So what I have to do, basically we know like we have how many element, like n element. So for n element we have make the n position like n right position, so I have to make the loop. Like first right position is n minus 1, and it will run till 0 I minus minus. Okay, let me, yeah. So for the right position is I1, like ith one. So for that I will make a loop, like as I discussed, j from 0 to till I minus 1. Okay, and j plus plus. And same logic I will write if my array jth element, like if my jth element is greater than j plus 1th element, then in that case it will swap. So for swap case, maybe I can pass array, and I have to swap jth element and j plus 1th element. And I will write this swap function here, static void swap. So in the array I am swapping, I will pass array a the indexes which I want to swap. So first I will store my index, first index, then I will paste my b index data, then after that my b index data will replace by my previous store data. So in this way I can swap the eth and bth value. Okay, so I just swap j and j plus 1th value, and as I discussed, like this loop is run from 0 to n minus 1, because this is I, like n minus 1, I is n minus 1, so like I minus 1. So basically it will run like, and we are checking j plus 1, so basically it will run an iteration for first one, and after that this I will decrease. So basically this I, what it is defining, it is defining the right position. Like for first one the right position was I, this one, this one. So now in the second loop, if I, my like my right position is this one, so I minus minus, so right position is this one, so it will swap that number of time. So in this way we can swap and get our data. Maybe I can run now. Yeah, compilation is done. Yeah, all the test case passed. Let me submit it. Yeah, so we can see it is accepted. So this is our logic which I discussed. Let me take the uh, second case. For that I have to remove that one. Okay, sorry. Yeah. uh, yeah, okay. Okay, so for the second, I am taking the example of selection sort, and we will learn how, like, what is the logic behind the selection sort. So in the selection sort, what we did basically, like suppose I'm taking the same example. Okay, let me make that. Yeah, so I'm taking the same example and I will use selection sort on that, so we can understand the algorithm behind this. So in the selection sort, what we generally did, um, like we will first find the like we will find the minimum element first. Like we will, like for every index, for like this is 0 index, this is 1 index, this is 2 index, this is 3 index, this is 4 index. So I will find the right element for this position. So which is the right element for this position, which is the minimum element. So first I will, like for every zeroth, like for every index, like in this case for 0 index, I will check what is the minimum element amongst this. So suppose I will check the minimum element, suppose I'm getting 10. Okay, so I will swap that 10 with the right position. So I will swap that 10 here, and that 29 will be go here, 14 will go here, 37 go here, and 14 will go here. Okay, so in the first check we can understood like this 10 is at the right position. Okay, okay, after that we will check on the remaining array. So like for this index, for one index, what is the right element? So among this I will check again the minimum element. So what is the minimum element? There are two elements, 14 and 14. So once I got the minimum element, just like when I got, like suppose I received this minimum element, so I will swap this element to the this element. So I will swap here, like this is already sorted, so I will just swap this 14 with the 29. So my 29 will come here. So now this 2 is at the right position, correct? So after that, from this index I will check among this array what is the minimum element, because that minimum elements is like at this, that should be at this second index, because this, that for that element the right position is second index. So I will check. So 14 is the minimum element, so 14 will come here. So in that case, like 10, 14, 14. Okay, now 37 and 39, 29 is remaining. So in the next check, I will check the minimum among them. So what is the minimum? 29. So for the 29 element, what is the right position? The third index. So I will swap to the third index. So now 10, 14, 14. Here 29 will come because that is the right position, which is the minimum element, and the 37 will come here. So like that, at the last whatever result we will get, it is sorted. So in this basically in the selection sort, it is not a bubble, it is actually selection. So in the selection sort, what we did, we will find the right element for the right position. Like for the 0th position, we will find the right element. So for the 0th position, what is the right element? Which is the minimum of all the element, which is the 10. For the one, like for the one index, what is the right element? So like at the 0 index already we have get the correct element, like, so we'll not think on that. Further we will check from the remaining element. So in the remaining element, what is the minimum element? 14. So 14 is the right position for the one index, so I will check here. So after that, in the remaining element, we will check the what is the minimum element? 14. So 14 in the right position for second index. So like that we will check, and we will replace with the right position. So in this way selection sort work. Like selection name said, we have to select the right element and select the right index. So that is named the selection sort. So let me write the code for the same logic. Okay, so as I discuss, for every index I will find the right element. So I am just defining the index like that, and okay, sorry, it is bubble sort. Okay, I have to hit selection. Okay, so I will take my index less than. Okay, so like first I will find the right element for this ith position. So what I have to do, as I discussed, I have to find the minimum value, sorry, minimum value index. So suppose I consider this ith element is the minimum value, and I will find the min index. So min index, suppose it is I now. So for the remaining element, I will check from j will start from I. Okay, and j go array dot length and j plus plus. So in the remaining element, I will check the minimum index and minimum value. If my min value, suppose if my array of jth value is minimum value, what I have to do, I will monitor my minimum value. So what is the minimum value in that case? Jth element, and my minimum index will be jth index. So in this way, for this ith position, I will find from I to like I plus 1, basically I can say from I plus 1 to the like remaining element, what is the minimum index, and after that I will swap that ith element with the minimum element. So I will pass my array and I will swap my ith index, because I the correct correct position of that minimum element, and minimum index like for that minimum element. So I will swap that element to the correct position. So in this way it will run. It is the like selection methodology. Let me run that. What it is? Okay, we didn't define the swap operation, swap method. Maybe I can copy, because it is the same. So I can copy here and paste. Yeah, let me run it. Yeah, all the test case passed. Let me submit it quickly. So basically here I did same thing, like for every index, like for every index for defining I, like we are checking for this 0 index what is the minimum index, like minimum value, and for that minimum value we will replace that minimum value with the ith index, because for that minimum value the ith value is the like ith position is the correct position, and for the next iteration from I is equal to 1, my iteration will start like remaining element, like from 2 to last index. We will check what is the minimum element, and I will replace that minimum index with the current index. So in this way, for every I, we will get the correct element. Okay, so it is done for selection sort. Maybe I can discuss about insertion sort. So let me remove this one. Okay, so it is the insertion sort, so maybe I can move this one. Yeah, so in the insertion sort, what uh, generally we did, it is insertion. Yeah, so in the insertion sort, what we generally did, like for every index, we'll check the like element from that index to the all the element present before that. Maybe it is not clear, but let me explain. Like for this I index, like for 0 index, I will check here this part. So for 0 index there are no elements, so we didn't have to check anything. But for this 10 element, for one of index, I will check in the like from start to till this index. Like if that element, like any element, like 29 is less, like 29 is greater than 10. So basically we have to find the right position for this 10 element. Basically in every iteration we will find the right position for the current element. So for this 10, what is the right position? So like this 10 is less than 29, so basically it will swap. So this 10 will come here, 29 will come here. Okay, 14 will as it is, 37, 14 will be as it is. So it is done. For the next element, like next element will be 14. So for 14 we will check from start to till this index. So 14 is less than 29, so we'll just swap that. So in the next iterator it will come 14 here, 29 here, 37 here, 14 here. Okay, again it will check this 14 and 10, but 14 is greater than, so it means this 14 is at the right position, so it is completed. Okay, it is completed for 14 is our right position. So in the next iteration it will check for this one. So for this element we will check from start to till this index, so we'll find the right position. So as I can see, like 37 is already greater than 29, we didn't have to do anything. So just will like go further. So 37 is as it is, 14 will come here. So for this one we will check again from start to end. So as you can see, this 37 is greater than 14, so we'll just swap that. So 10 will come here, 14 will come here, 29 will come here. This 14 will swap to 37 because that is 37 is greater than. Then again it will check this 29 to 14, 29 is greater, so it will again swap. 14 will come here, 29 will come here, and 37 will come here. Now this 14 is equal to this 14, so it will not do anything, and at the last we will get the like sorted array. So in the insert sort, what we did, for every element we will check from start to till that index where the element is present, and we will find the right index of that element before the index. So maybe I can show in this here, maybe it will be more clear. Okay, let me sort it. Yeah, so like for it is starting the iteration from 50, so it will just took this index, one index 36, so 36 is less than 50, it means we have to swap it, so it will just swap that 50 to 36. So now it is done. So next element it will check 39, and for 39 it will check from 0 to 0 to 1 index. So it will check like 39 is 50 is greater than 39, so it will swap basically. So we can see here it will swap, and again it will check like 36 is less than 39, so it means the 39 should be here, so it is now done. So for 13 element, like for third element, again it will do same thing. It will pick that element and it will compare with the previous element. So basically from 0 to that element, from 0 to 2 element, it will iterate, but it will start iteration from the just neighbor element, like from 2 to 0. So it will compare 13 to 50. 50 is greater, so it will just swap that. Again it will compare 39 to 13, so 39 is greater, so it will just swap that. It will again compare 36 to 13. 36 is greater, so it will swap. So now in this position the 13 got this right position. So in the insertion sort, basically for every element we will get the right position and we will swap till we get the right position. So in this way that element will present at that right position. So in the next iteration 35 is also less than 50 because 50 is greater, so it will swap, and it will swap till when it will get the right position. The right position of 35 is at the 1th index, so we can see it will swap, then it will come here right position. So in the insertion sort, basically we will do like that. So let me write the code for that. Yeah, so insertion sort. So in the insertion sort, what we are doing, we will loop I0, I less than, and I plus plus. So for every ith value we will make one like we will iterate from that ith value till 0, correct? So I will just iterate from I minus 1 from j, and I will store that number as well because I can compare. Okay, so I will loop till j greater than equal to 0. Okay, because from that index, from I index till start. And if my array element is greater than num, so what I have to do, basically I will swap the neighbors. So basically what we can do, like instead of swapping by this element, what we can do, like for every element we will find the right position. Like if I am considering this element, so for this element what we are doing, let me explain you. So for this, suppose I am considering my ith index is here. So for this element I am checking j is I minus 1. So I minus 1, and what I have to do, like I will basically check the right position for this 14. So what I have to do, like I have to check this 37 is greater than 14. So I will just swap, like I will replace this 40 to 37, and I already stored this 14 in the variable num, as I said. And again I will check this 29 is 29 is less than, okay, 29 is also greater 14, so I will just replace here. So 37 will replace 29. Again this 14 is equal to 14, it means it is the right position for 14, so I will just swap this to 14. So in this way I'm just going to do it. Is just a different version, but it is just working like same methodology. So what I have to do, if my like j value is greater than num, so we are not, because that is not a right position, so I will just swap data. So I just replace the data, and if any case, like any value, any AR of j is less than num, it means that is the right position. So for that I will break that loop. It means my j is at the right position. So at the last, what I have to do, and in that loop I have to just decrease my j. Yeah, so it means if this condition failed, it means j is less than num, it means that is the right position for my num. So what I do, I'll just replace my j plus 1th value with num. Why I am replacing j plus 1th value? Because like every index, like if my aj is less than, like aj is less than num, so it means after that num will come, correct? For, like I can explain here, like if any element come, like in this case we are coming here, like for this 14 we are checking, so this 14 is less than or equal to my this 14. So what is the right position? This 14, this j plus 1th position, so here, not here. because when we replace the here, then we will lose one element. So j plus 1th will replace by num. So in this way the selection sort work. Let me run it. So all the test case passed. Yeah. So in this way we can write the insertion sort. Basically we are just like for every index, for every I is equal to 0, like 0 1 2 3, we are just iterating from minus, like from suppose I am on 5th index, so I will iterate from 4 to 0, and from 4 to 0 we will find the right position using this while loop. And if I got the right position, so I will just replace the right position plus one value with the our number, and in this way we will find the right position for every number. For like in this case, for this number we are finding the right position and we are just replacing that data with the num. So in this way we can write the insertion sort. So I hope you understood all this three sorting, and maybe you can practice and you can visualize on this platform like Visualgo. It is a very good platform to visualize every algorithm, and on this coding ninja platform we can, like, you can write the code for every sorting. So yeah, if you write okay, let me discuss quickly the time complexity. Okay, so you can see, like, for every sorting, suppose for bubble sort, let me check the submission. Yeah, so for bubble sort, what we are doing here, we can see, like, this I loop is running n time, and for every n iteration we are looping this loop till the n, like at most. Basically I'm considering the worst case, so it is just n into n, so it is a n square operation. So it is a total time complexity big O of n square. And for selection sort, we can also see we are making this an iteration, and for every an iteration, like, we are checking, suppose we are at the right like last index at the n index. So for n index we are checking n minus 2 0, or we can see, like, sorry, it is a selection. Yeah, so for every, like, for 0 index we are checking one index to till the n index. So for every element in the worst case we are checking the n time, so it is total n into n, it means big O of n square operation. And in the same way for insertion sort, we are also, like, for suppose my I index is an n index and I am iterating this j loop from n minus 1 till 0. So in the worst case it is also a n square. So for this three sorting, in the worst case, basically in the worst case we are getting the big O of n square solution. Well, like, it is a big O of n algorithm, sorry, n square algorithm. So I hope you liked my video, and I hope you understood all these three sorting. And if you like, please like my video and subscribe my channel. Maybe I will share the next sorting, like merge and merge sort in the next class, so you can get a notification and you can learn how we can write the code for that. Yeah, thank you for watching my video.